Alright, welcome to the 26th episode of Creating Swish, which is a closure for Swift. And I'm using Claude code to do it, to learn agentic programming. Please like and subscribe. If you want to support my work, buy me a coffee. Link in the notes below, the show notes. So, this is where we're at. We just have a few, about 20 skips left to pass the Jank Clojure Suite. This includes hierarchies, which I'm not sure we're going to do. Requires Swift interop and classes, and it's kind of a JVM thing. The other big thing to notice is we'll have multi-methods, and we'll definitely do that. So here's what we've done so far. We've got, I'm not going to go over every function, but I'll point out some significant things. We've got watches for atoms and stuff, atom synchronization, agents and validators, futures and promises, all the concurrency stuff, including software transactions. We have protocols. One note that they do not work on the built-in types such as into double, just on types that you define with yourself, like with def type or def record. Bit functions, more Boolean. We've got the case statement now, which is nice. We've got an eval function, which Lisp is famous for. We have a format function. It just supports the basics, not all the little idiosyncrasies of closures, and it's more tailored towards what Swift gives you. What else? Rationals, rationalize. So all those functions, and like I said, we're down to these skips. Now I've got a few demos to do. And first let's look at a concurrency demo that just shows off all the concurrency functionality. So we've got, well, let's just run this and I will go over it by hand. So if I clear this, alright, so we've got showing off atoms. We're creating a counter atom, and then we have add a watch to it that prints out watch fired whenever it changes, and then we do a swap and increment the counter, and it prints out watch fired. Now it's 11. Is that right? No, it went to 1 first. And it's printing out the old and the new. And then we have another swap where we add 10 to it and we get 11. And our final counter is 11. Now let's look at futures. We create a future that is just going to sleep for a long time with the new sleep function and add up 5 through 1. So we first ask if that is a future, and it is. Then we ask if it's realized, and it's not yet. And then we dereference it, and it waits, and it gets the final result 15. And then we ask if it's realized, and now it is. And then we also do the same thing with the slow future, and we cancel it. It sleeps 10,000 seconds, and so we cancel it and it returns true, and then we ask if it's canceled, and that also returns true. Next we have promises, and And so we create a promise, and then we create another future that sleeps 50 seconds and then delivers the answer of 42. And so then when we dereference that future, it waits and we get 42. Agents. So we create an agent, a total agent, and then we go 5 times, we tell it to add that number, and then we await that, and we get 10. Let's look at validators. Okay, so validators and the restart agent. So we create an agent with a validator that has to be a positive number. We send this function to the agent that subtracts 10 from whatever argument. And then we await that. So that would go non-positive, and we get our validator says invalid argument to send, and then we reset the agent, restart the agent to 1, and we get well, now it's nil. Error handling. We add another agent called resilient, set to 0. Then we set an error handler for it that will print handler saw exception when it gets an exception for that agent. Sorry, let me go back to where we were here, error handling. And so then it prints just a message here. And then it sends this function to the resilient agent that throws an exception, and we get printed out handler saw exception, boom. Then we set an inc, and we get 1. We wait for that agent, and so it swallowed the error and kept on going. Let's look at references and STM. So we create 2 references, one for checking and one for savings. We have a transfer function that does a transaction where it takes an amount from account and adds it to the to account. So we call this transfer with a checking and savings of amount 30. And so when we get that, and then we print out the result in each one after dereferencing. So now checking has 70 and the savings has 130. And then we create a reference for hits, and we increment the hits twice, and we get 2. Then we're ensuring the checking. I'm not sure what that does, ensure, but. And then we have some concurrent transfers. We have an account A, which is a reference of 500, and B is also a reference of 500. And then we have a move function that moves from A to B. And this is showing that the do-sync keeps the total consistent under contention. So we we do a bunch of transfers. Oh, we have a transfer function as well that does 20 transfers and moves 5 each time. So we have a bunch of transfers going on, and we dereference those. And so 20 concurrent $5 transactions, and we get 400, 600. When we're in, the total should still be 1,000, which it is. And last but not least, we have this bound_fn function, which with carrying dynamic bindings across threads. So we created dynamic binding for a user set to guest, and then we have a who am I function, and it sets the binding to Alice, and then it prints the who am I captured the user as Alice at creation time. And now we're going to bind it to Bob in a future. And then, but when it's done, it's back to Alice. All right, so now let's show the protocols. So we have a demonstration of depth protocol. We create a shape protocol with 3 methods: area, perimeter, and describe. And then we print out the protocol, which is just prints its name, its shape. We have def type. So now we create a circle with a radius, and it implements that protocol. So its area method will do pi times the radius squared, and then the perimeter and describe will say circle. And there's two different arities for describe. The second describe will have a prefix. So we create this circle with a radius of 3, and then we print out the area and the perimeter, and we describe it, and we get a circle of it, radius 3, and we describe it with a prefix. So then we have a demonstration of polymorphism with one function, many implementations. So we have a bunch of shapes. We have a circle, a rectangle, and a circle, and then we map the area onto the shapes, and we get the area for the different shapes. And we map the describe on the shapes, and we get the different descriptions. So that's happening. And then finally we have records. So we create a record that is a square that just has a side, and it implements the protocol. Again, area, perimeter, describe, and describe. And then we create a square with a side of 5 each, and then we print the area and the side. And this is also demonstrating that the record keeps its map-like behavior. And we add we change the size to 10. Now we ask, is it a map? It still is a map. And now we map area onto on shapes and square. So we get an additional area. And then we're going to do it with def type. Def type is not a map. It's just whatever behavior it has. So we ask if it's a map, it's false. We try to get the radius. It's nil because it's not a map. And we try to associate radius 9 with it, and it throws an exception. Yeah. All right, and then we show here that we can extend the type and we create a protocol called nameable, and then we extend the circle to implement nameable, where it just has a label method that prints a circle, and then we print what we call label on the on that circle, and we get a circle. And then we create another greet protocol with the hello method, and we extend circle with greet and rectangle with greet, and they just say hello from circle, hello from a rectangle, and you get those. And we also show that we are implementing just a plain extend. So we create another protocol called describable with a blurb method, and we extend nil to implement that. So extend is a raw method map, including a default implementation on nil. Okay. I wasn't familiar with that. We extend nil to have a describable, to implement describable, and it just prints nothing here. So when we call it blurb on nil, we get nothing here. We also have the satisfies extends and extender instance method. So satisfies shape. Does C satisfy shape? Yes. Does shape satisfy 42? No. Does nameable, does circle extend nameable? Yes. Extenders of shape is proto circle, rectangle, square. Is C an instance of circle? Yes. Is C an instance of rectangle? No. And then finally, we have a calling protocol with no implementation throws. So we have a def type of a triangle which has a base and a height, but it does not implement the protocol. And so we try to call area on it, and we get an exception. No implementation of method, area protocol. So that's a demonstration of protocols. So that's what we have so far. Let's bring back our list of skips here. Also, one thing of note, this is not a pure duplication of Clojure. We have made some changes to get things to implement easier, or things it doesn't make sense to implement right now. And that all those things are noted in Claude.md, and eventually, once we get the Jank Clojure Suite passing, then we can go back and address some of these issues where things differ than Clojure. And so we'll address these skips going forward, with the main feature being multi-methods. So I hope you like that. Again, please like and subscribe. Buy me a coffee, and if you're interested in this stuff, let me know. If you have questions, let me know. Put them in the comments below. If you need help writing your own language, need help with anything, writing mobile apps, whatever, hit me up. Thanks. Talk to you later.